Alright, for this problem, we want to solve the following logarithmic equation. Log base 2 of x is equal to log base 4 of 100. And we need to consider the equality property here. Because if the left-hand side of this equation, log base 2 of x, is said to be equal to the right-hand side of the equation, log base 4 of 100, that means that we need to change the bases so that they are equal. We have a base 2 right here, and we have a base 4 right here. And when we look at that, the only way that we're going to be able to change one of these so that it resembles the other base is by using the change of base formula. Now the change of base formula is simply stated log base A of B is equal to log base C of B over log base C of A. And we can use any base that we want to, so C can be any base we need. And if C is going to be any base, it would make sense that we're going to go ahead and look at the base 4 and change that to base 2. And that way it will resemble the left-hand side of the equation. So log base 4 of 100 is going to be rewritten using the change of base formula. And what we're going to do is we're going to go back over here and we look at the fact that A in the change of base formula is going to be the 4 right here, and that B in the change of base formula is going to be the 100 right here. And then, as I said, we can choose C to be anything, so we're going to let C be equal to 2. Now, when we change this up, we're going to end up with, we'll have log base 2. And remember, we're going to use color coding here. And then we're going to have B be the 100. So it's log base 2 of 100. And that's going to be over log base 2 of 4. Now that we've rewritten log base 4 of 100 as log base 2 of 100 over log base 2 of 4, we can go ahead and simplify. We're going to use the transitive property of equality that allows me to write log base 2 of x from the original problem, which is equal to, remember, log base 4 of 100, but we also know that log base 4 of 100 is equal to this right here, so it's going to be equal to log base 2 of 100 over log base 2 of 4. Now the problem is we need to go ahead and rewrite it so that we have a single logarithm on the right hand side. Now it's very easy to find log base 2 of 100 and log base 2 of 4 using a calculator, or using the fact that log base 2 of 4, or any log base A of B, is going to be equal to the equivalent function where I say that a to the y power is equal to b. Now what that means is if I have log base 2 of 4, I'm going to use this particular method, and I'm going to rewrite it simply as 2 to the n power is equal to 4, which means in order for this to work, n must be equal to 2. So that means that this whole thing right here can be rewritten as 2. And so now I rewrite my equation as log base 2 of x is equal to log base 2 of 100 all over 2. And I'll go ahead and write it in red so that we can see exactly what we're doing. Now, once again, I'm going to do a little bit of simplification. And one thing that you have to remember, that math is all about manipulation. And I'm just manipulating this by rewriting it in equivalent forms. I have not changed any value, I'm just changing the way it looks. And now I have 1/2 log base 2 of 100. But remember that if we have an coefficient in front of a logarithmic expression, it can be rewritten as an exponent. So I can look at 1/2 times the log base 2 of 100, and I can rewrite that by taking this right here and using it as an exponent. So I end up with log base 2 of 100 to the 1/2 power. And this 1/2 definitely works on just the 100. But since 1/2 as a rational exponent is the same thing as saying the square root, this means that I have log base 2 of the square root of 100. And the square root of 100 is 10, so this is equivalent to log base 2 of 10. And this I'm going to go ahead and put right back into my equation because I'm letting this right here be equivalent to this right here. So now I have on the left-hand side my original left-hand side expression, log base 2 of x, but now I've changed what I originally had on the right-hand side, so it looks like this, log base 2 of 10. And by the properties of equality in mathematics, if everything is equal, then this variable in the argument for log base 2 must be equal to this argument in this log base 2. Therefore, x is equal to 10.